Gold.
Can you hear me this time?
No, I can't.
Oh, dude. Look at this guy. Look at this guy with the jokes, bro. Man has some jokes. What's up, Internal?
Bro. Every time I see the fucking notification for office hours,
Yes,
it just
sir.
comes out the first letters OF, and I'm like,
Oh, OnlyFans? I'm not that desperate yet.
They got their own OnlyFans. Damn, they growing.
Bro, you know OnlyFans was originally created for like legit stuff. You know that?
Yeah.
It was originally
But
created,
niggas
I think,
took
for like
advantage
for
of it.
gym teachers. It was originally created for like influencers and stuff to be like, hey, like be a fan of my gym teaching and stuff.
It's still, you can still use it like that, but it's because it took over the industry of adult
Adult
viewing,
stuff.
so
Well,
instead
it took over all the simps.
so
That's what it did.
Yeah,
All the
so
simps, dude.
Instead of using it for that, they decided there's more profit for adult shit.
More profit in
So they
porn, dude.
started- Hell yeah, money's everything in this world,
Well, I mean, sex is everything, so sex is money. Yeah, I get it.
bruh.
Sex sells, is what they say. It's unfortunate. Anyways.
If you got enough money, you could get anyone to sleep with you. So, of course, money, and everything.
I don't know, going that
It's
far.
money and
Probably.
sex.
They're all
You
linked.
could basically, yeah, they're.
I agree with you.
Like,
I agree with you.
I feel
that.
like people say that money doesn't buy happiness, but to be able to get the stuff that makes you happy causes money now.
Oh, for sure. I always say when someone says money can't buy you happiness, I'm like, have you seen anyone cry in a Rolls Royce? I haven't seen anyone cry in a Rolls Royce.
Exactly.
Don't happen, dude. No.
People do cry but don't post that shit.
They don't post that shit. They only post the good shit. Nice,
It could
dude.
be depressing tears, thinking about all the shit they had to do to get where they are now, or
Yeah.
it could be happy tears saying that I finally made it out of the gutter.
Yeah, dude, I made it, dude. Dude, I'm just trying to pay rent, dude. That's all I'm trying to do. I'm trying to pay rent and help kids.
Right now,
That's all I'm trying to do.
but you gotta admit, you're trying your best to at least survive.
Yeah, it's rough out there. I don't know.
That's what we're all doing right now. But
That's
one
what
day
I
I want to be able to say I made it. I made it out of the gutter. I
Yes,
made
sir,
it
dude.
Out of the ghetto where I grew up and was born.
Hell yeah. Dude, that's great, Ramiro, that you have that drive, dude. That's the most important thing, man. Most important thing is to have that drive. Hell yeah.
Yeah. Like right, the moment I turned 18, I turned 18, I opened an account with
Good.
America for fucking IRA shit. You know. Roth
Wow, you
IRA.
already got a Roth IRA, dude?
Yeah, so I'm just waiting
That's
till
good
I'm
for you,
in
man.
my 50s to be able to like
Retire.
retire. Yeah, so
I don't think I'll ever
decided
retire, honestly. I don't think I'll ever retire. I think I'll just keep doing this shit till I die.
When I say retire, because I mean, this for you technically job and same time it's a side thing.
Sure.
It's something you like doing, being able to enjoy it. So
Yeah.
instead of retiring, find this more like a hobby now that you.
Yeah. I don't gotta
have
worry on it,
job.
but for income and stuff, I agree.
Yes, you just gotta worry about the kids, about what you
Yeah.
like doing.
Yeah. Well, they say, like, if you find a job that you like, you'll never work a day in your life. Right? You know, if you like what you're doing, and which is very nice if you can do it, but do you just
Time
when we
passes
start?
by way too quickly.
It does. All right, the kids are asking when am I starting, so I gotta start. Good hearing from you, Ramiro, though, dude. I appreciate it, man, dude. You're always cool.
Oh yeah.
All right, cool. Let me start off the stream.
Nah, I'm one of the coolest niggas you know.
And you are one of the coolest guys I know. I'll give you that, Ramiro. I love you, dude.
I forgot I can't be saying that anymore on here.
Hey, you're good. All right, welcome everyone to Office Hours. My name is Dr. Gold, Actual Education. Stream that helps you out with math, homework, science homework.
I can't see the screen on Discord.
Oh
You
yeah,
can
let
turn
me
it
know. No, I'm not sharing it. I fucked up. I fucked up, dude. I got to there we go. Now it should
on.
work.
Hey, good. Siempre haces el mismo, ¿verdad?
Siempre haces what? Always the same shit? Is that what you said? Always the same
Yeah.
shit? Always the same shit.
Oh, you understood. I'm proud
Of course,
you.
dude.
That's dope.
I dated a Colombian chick for 6 months, bro, dude. I had to speak Spanish.
Of course, because then you never know. She talking shit about you.
Yeah, or like it's the only way for her
She
to like message things back to me, dude. You know.
Nah, she could have been like, tiene el pito bien chiquito este güey.
Did you just say I have a small dick? Like, what'd you say?
She could have been like, this nigga, this dude has a small dick.
Yeah, see, I understood that. All right. Let me start with some math questions here. What's up, Diva? Diva, we're learning about multiplying fractions today. What's going on, dude?
I used to hate these.
Yeah. No, they're not bad, dude. They're not bad. They're not bad.
No, I'm saying I used to hate them when I was
Oh.
when I was in middle school and we used to need to do that. That shit was the worst.
Shit was the worst, yeah, dude.
God damn, she got fat ass.
All right, Diva, do you know how to do this? I mean, like, multiplying fractions isn't like the worst thing for easy numbers. So, for instance, if I had something, I don't know, let's say I had 3/4 times 5 seconds, right? Yeah, let's try that. Dr. Olga, are we gonna do my question from last stream? Do you have audio? Like, can you hear me, Teacup, or I just can't hear you? It's okay if I can't hear you. If you can't hear me, there's no point to this. Yeah, he was like, my audio doesn't work. Well, I don't know. It's kind of hard. I have to be able to talk. You have to be able to listen to me to teach, you know.
Sure.
But anyways, when you're multiplying fractions, Deba, all you got to do is just multiply through the top and multiply through the bottom. Okay. All right. Good. Teacup. Okay. Cool. I will get to yours. So this is 3 times 5, and then this is 4 times 2, which is 8. Not your friend. I think you're next. Not your friend. Are you not? Or you're like third? But Equity's not here right now, so I can do yours next. Yeah. Okay. That's fine. All right. Yeah. You just multiply the top, multiply the bottom, goes all the way through, and you're done. Right. However, this can sometimes get complicated. Right. Let's say, for instance, I had 10 over 3 times, I don't know. Let's make some let's make some things like kind of crazy. Let's make it crazy. We're gonna make this shit crazy, dude. All right, let's do like 4 over 27 times 9 over 16. Okay, this looks pretty difficult. Yeah, Equity says I am here. Okay, Equity, you are here. All right. Equity, if you give me a chance, yeah, let me do Not Your Friends like after this, just because he has to leave. Because dude, Not Your Friend. What time zone are you in, dog? It's like 6 a.m. for you, dude.
God damn.
Wait, Monkey says I can't hear you. Monkey, can you hear me? I guarantee you can hear me. What do you mean you can't hear me? You should be able to hear me, no? Also, wait, 1 second. Let me make sure my sound levels are okay on this, because this does, like, sometimes mess up. That's the worst, dude.
Sometimes.
Siempre cierres. What is it? Siempre. Oh, there it was messing up.
Siempre
Okay.
hay problemas.
Siempre es problemas con esta. How do you say sound in Spanish? Rumor?
Con este sonido.
Con el sonido. Yeah, okay.
Con
There we
este
go.
sistema de sonido.
Sonido. There we go. Yeah, that's what it is.
Sistema de sonido.
Sistema de sonido. Audio system.
Sound.
I like that, dude.
Yeah,
System
audio
sound. Nice.
Because if you just say sonido,
It's
more
just
like,
sound. Yeah.
Yeah. It's just
Yes.
voice.
Nice, Not Your Friend. Three stream watch streak. That's great. In school, I'm like, we divide 4 by 16 and by 4. Yeah, so here's what we would do, right? So I could multiply this all the way through, right? I would know this would be 36. But then this, like, I don't know how to do that. I'm just like,
Stop it.
no, don't do that.
Get some help.
We can get some help. We don't have to do that, dude. So the way to do this one is to, because I don't really know how to do 27 times 16. That sucks.
Nah, but what's funny is there's people who do know how, and we doing it way too fucking quick.
Yeah, well, they can do it with the calculator and stuff. But what would make it easier would be to, like, kind of look at these and look at this. So this is the cool thing about multiplying stuff. If you have, like, A times B, that's the same thing as B times A. You can always just switch the orders of things. I think it's called, like, the commutative property or something. So I can just switch the orders of these. So I can make this 9 over 27,
Oh, then
right?
you just divide.
And then exactly, you got it, Ramiro, right? And then times 4 over 16, right? Now these, like by themselves, these are a lot easier to simplify, right? Because what's 9 over 27?
3.
1 over 3. This is 1 over 3.
Yeah, 1 over 3.
Good.
My bad.
You're good, dude. And then this is 1 over 4, right? You see how this is 1 over
So long
12?
since I've done this.
Well, it's good. It's a good refresher, dude. But see, that's how you do it. That's a lot easier to do, right? Than to do this. This would suck. Don't want to do that. Okay. So Deba, doing this one, I'm going to just write it out again. I think I see here. I see 25 times 8 over, 25 over 7, sorry, times 8 over 15. Where do you see maybe
Oh,
that there's
was like
something...
75. I was like, what the
Yeah,
fuck?
this was 75. That would suck. I hope it's not 75. I think it's 15 Deba, right? Is it 15? See if it is. Yes. Okay.
Yes.
Yes, he says. All right. So Deba, what would be easier, right? 8 times 25 isn't that bad, and this like isn't that bad either. But we can make our lives a little simpler. You know, I always say like work smarter, not harder. You know, you got to work hard at some point, but like don't work too hard all the time. See what Diva says.
It's work hard right now and live a pretty easy life later on.
Oh, there you go. That's a good thing. Yes. I have a lot of quotes about that. Diva says I am sick, so my friend sent me homework. Oh no. Sorry you're sick, Diva.
Fuck homework.
Yeah, fuck homework, but fuck being sick, dude. Fuck being sick. Being sick sucks. Exactly. So what I can do here, Diva, is let's just switch these. Watch what I do here. Someone wants to speak. What's up, Swaz? Come on up. How's my boy Swaz doing, dude? What's up?
Yo, what's up, dude? I was just wondering, what program do you use to draw on? Because I was wondering if I could get some help from my buddy on some of the questions I put into the help screenshots because we're in the same class.
Yeah.
Just because I want to be able to do it with him, you know?
So this one I use is like a proprietary thing I use for on the stream. It's called Group World, and I think they have like demo accounts and stuff. But the ones that I've seen people use to help like each other, just like, you know, doing whatever. I think it's called Microsoft One something. Microsoft One. Is it called Chalkboard or something? I think this is the one I see people use, or Microsoft Whiteboard. People love using this
I know
one.
what you're talking about.
Yeah, but you can use this one on the web. I use this, Swaz.
Okay.
I use this. So I use Group World, but I pay for licenses and stuff to use this online. You see, like it's kind of pricey. But I always
I was just wondering.
No, but even with Whiteboard, you still gotta buy the fucking Microsoft 360 shit.
Oh, do you? Do you still gotta pay for it, dude? That's kind of
most of the time, yeah. No, everything with Microsoft, they be trying to charge you for anything. But
trying to get the cash.
If you're in school, what are you in college or in high school?
He's in high school, I think.
I'm in high school, yeah.
In high school, what system does your school use? If your school uses Microsoft too for like the schoolwork and shit, you could use that
we're
account.
Chromebook, dude.
Chromebook.
Oh, they're Team Google, dude.
Yeah, my school uses Microsoft. So because my school uses Microsoft, I'd be taking advantage of the account.
Yeah, they give you all the stuff.
Yeah,
there was
so
another
I'd be taking
one.
advantage of that.
Wait, online.
You know what? Me and my buddy just might do Discord Paint.
Oh yeah, there's something like that, isn't there? Yeah, dude, man, what was the one Hypatia was
There's
using?
A lot of glitches with it though.
Is it Canva?
I appreciate it. You don't have to do my questions tonight because I'm gonna get help from my friend, but I appreciate it.
Okay. If I have time, I'll just do them anyways, and I'll send you the screenshots, bro. You're good.
Okay, I really appreciate that, man.
You're good, dude.
Canva's pretty good too. Only issue with Canva is that it's more like for projects.
Oh, Jamboard. Equity says Jamboard. Jamboard is cool too. All right, thanks, dude.
It's more like for projects or stuff like that. Canva, it's a pretty good thing though. I love using Canva. I always take advantage of the free 30 days.
Jamboard is owned by Google. Oh, there we go. So yeah, let's send that to on Google Meet. Oh, that's very cool. Oh yeah, let me tell Swaz that then. Swaz. There you go. That's a cool one. Jamboard. All right, sorry, Equity. Yeah, let's finish your question real quick. Yeah, you're right. So, sorry, not Equity. Sorry, Diba. So you could do 8 times 25 is 200, and then you could do 7 times 15 is, what is that? That's 105. But if you want to be like a little bit smarter with this, you can just simplify this first, right? So 25 over 15, I can divide both these things by 5. And so this is going to become 5 over 3. And do you see how this is now a lot easier? Because 5 times 8 is just 40, and then 3 times 7 is 21. Right? I think that's a little bit easier to do. Cool.
Everything's pretty easy.
Everything's easier. Nice.
Once you start learning the subject and start understanding it, it's easier and easier.
Yeah.
Practicing.
You got to keep pushing, dude. That's what it's all about, dude. It's all about just keep pushing, man. I agree.
The more you start paying attention, listening to how other people solve it and show you how to solve it, just pay attention. Whatever you find easier, just use that.
Find your own way. That's what I always say. Like, your teacher's going to teach it one way, which is the generic way that most students learn. But, like, the most people get it. But you may only understand it in a certain way. And that's why you guys have YouTube, you have TikTok, you have all these resources. You can find a specific explanation that works for you, you know?
We got Dr. Gold.
You got Dr. Gold. All right, Deba, I hope you feel better, dude. Hope you feel better. It's 1:15 a.m. Y'all are in some weird time zones. I think Deba's in the UK or something. Or Debo, where are you? Not your friend is in Sri Lanka. It says it's 6:15 in the morning for him right now. That's super early. Okay, here we go. Let's do this one. All points A, B, C, D, line of circles shown in the figure such as AB.
I fucking hate circles.
Yeah, you love circles, dude. We love circles, dude. We love the circles. No, we love the circles. Circles are so great, dude.
I hate them. It's horrible when you involve circles. It's not hard. It's just annoying. There's a lot of equations.
It is. There's a lot of theorems, dude. It sucks. Okay, anyways. All right, so AB equals BC, and then DC is perpendicular to AB. Okay, cool. This is perpendicular to this. I like that. That's great. A tangent line is drawn at AL, so this is tangent. Cool. We know that. Copy the information script and conclude the above information. Join DB and AC. Okay. All right, what is it? Join DB. Okay, so we're going to join this. So this and this. Is that what they're saying? Join these two. And they're saying if angle LAB, so LAB is equal to 35 degrees. So they're saying this thing, this girl right here is. All right. Good to see you, Ramiro, dude. Take care, dude. I'll be in Houston, actually, next month. Next month, I'm going to be in Houston.
Yo, let me know.
I'll come say, we'll come get some tortas and some micheladas. No, I'm down.
Hell yeah. I'm going to take you out and eat. Wow.
All right, dude, we're going to eat good. We're going to eat good. We're going to eat good, Ramiro. Yeah. All right, dude. Good to see you, man.
Good talk to you. Been a minute. Bye.
Peace. All right, they want the magnitude of angle BAC. Okay, so they want this. Oh, interesting. And then show that DB is parallel to AL. Okay, well, showing that, right? So if DB is parallel to AL, not your friend, right? That means that this angle must equal this angle, right? We got basically, because if this is alternate interior angles, right? That would be great. Okay, cool. So let's try to see what's going on here. Okay. These two equal each other. Okay, great. Uh-huh. Which means it's an isosceles triangle, which is kind of nice. I like that. Man, there's going to be some circle theorem here. And then we say that... Okay. Let's see. Always, I love to draw transversals here. Not your friend. So, I know that... Here, I'm just going to put the green line as the parallel lines. So, I know that these two, right, are parallel to each other. Okay. Which means now we got some transversals being set up, right? Because this whole thing is a transversal, right? To which point I know that this angle, right, must equal this angle. Okay. Is that going to help us out? Oh, we're getting close. We're getting very close here, dude. Ooh. Okay, let's see. All right, so I know... here, let's use a different color for this. This angle is equal to this angle. Can I show that this is 90? That's kind of what I want to show, but I don't know that this is the center yet. Oh, okay. Wait a minute. Geometry, my favorite. What's up, Zach? Yeah, interior angles are equal. Okay. Here's the other cool thing here, right? Because BC is equal to AB, this is an isosceles triangle, right? This is isosceles. Which means that the opposite angles within an isosceles triangle are also equal, right? So this one has to be equal to this one, okay? So that tells me this has to be equal to this. So yeah, maybe let's say some things real quick here. So angle, just to give you like a little bit of proof. So angle BAC is equal to angle DCA, and that's alternate interior. And then we can say that triangle ABC is an isosceles. Because AB equals BC. Good. And then we can say that angle BAC equals angle BCA. And that's, opposite things of a isosceles. I don't know what the exact rule is. CBD is also equal to that. Let me see. CBD is also equal to that. Angles at the same sector theorem. What's angles at the same? I think I see what you're saying. You're saying that this must equal this. Why is that? No. CDB. Oh, CDB. Okay. Oh, because yes. Okay. Because this, right, picks out this sector, which is the same length as this picking out this sector, which is the same length. Is that what we're saying? Yes. Okay. I agree with that too. So angle CDB is CDB is equal to, well, we'll see how that helps us. CDB is equal to CBA, right? Yeah. Or what did I say? BAC? BAC? Yeah, BAC. Okay, so all these angles are just equal to each other. Okay. And then if this angle equals this angle, which equals this angle, can I also say from a sector theorem? Well, no, because I don't know what this sector picks out. Oh, that's unfortunate. Yeah, and I don't know that this is the same side either. Okay, that's all right. That's all right. I would like to say something about these two, which would be nice. Oh, wait a minute. Here's another transversal here, right? Here's another transversal. I can say that this equals this, right? That's another alternate interior angles. So I can say that angle ABD is equal to angle BDC, or was it CDB? What's up, monkey? Yeah, that's also alternate interior. This is same sector. Okay. Well, at this point, I'm like, dude, everything's just going to be equal to each other, right? And then, I know, right? That this has to equal this by alternate interior. I'm just going overkill in the angles, and eventually something will click. Let's call this, like, point F. Let's call that point F. So let's say that, like, DFC is equal to angle AFB. And that's vertical angles, I believe. Which, if that's true, we don't know what this is, though. Man, I need this last one, though. How do I get that last one? BAC. We're trying to get this. That's what we're trying to get. We're trying to get this eventually. Okay, what does this correspond to? This corresponds to, like, something like over here. Does that help me out? Because then this is a triangle, maybe. See, problem is I don't know if this goes through the center, the radius. It would be nice to prove that this is the center, and then I know this is 90. That's what I really want. I don't know if I can prove that that must be the center, though. I guess, okay, wait a minute. DF equals CF, yeah. And CF equals FB. Yes, I agree with that. Yeah, very good. That's exactly what I was going to say. If I can prove that this equals this, then, and and then that this equals this, that has to be the center, right, of the circle. CBD is also equal to the angles CBD. Let me see one second. DF equals CF. Yes, I agree with that. Okay. Yes. Man, we're drawing so many triangles and circles today. Yeah. DF equals CF. And then we said that AF equals FB. And that's sides of this. Yeah. Yeah, that must be the center because all the angles are equal. Wait, did we prove what this one is? Sorry, did we prove what CBD? Did we prove this one was equal to the other one? How do we do that? I agree that this is equal to this. This is equal to this. Okay, well, we know that these two equal each other. And these two equal each other. But I don't think we know that these two equal each other yet, do we? I mean, all the angles are the same. Oh, wait. But we have side angle side. Yeah, you're so right. Sorry. Because I do know that DC... Wait. Yeah, it's because AB... Now, wait, yeah. AB equals BC. Okay, side angle... Side... But no, side angle is not the same side. It's not the same side. AB. I know that this equals this. Because all angles, yeah. Well, how do we prove this one was the same though? That's my question. Hmm.
Hey, Dr.
What's up, dude?
I'm doing okay. Tomorrow I have school.
Everyone at school? Yeah, I think a lot of people have school today.
Yeah. Also, I got like my kind of Python advanced grade, and I got
Nice.
88.
How'd you do?
I got 88%.
Nice, almost an A. Getting up there, getting close.
Yeah, but Dr.
What's up?
I had to use AI for some help because it was way too advanced that I couldn't even figure out how to do stuff. It was just little though.
Oh, okay, well that's all right.
The teacher said that he will be grading a little harder this semester since it's more advanced.
Yeah, that makes sense.
But I really do hope I do well.
I think you will, Ethan. Sorry, I'm
Okay.
stuck on this one. One sec. What am I missing here? Not your friend, dude. Yeah, I would like to prove that this one's the same. Where are you getting the opposite interior angle from? Opposite sides are equal. Yeah, I don't know that this side is equal to this side though. I don't.
Is this circle theorems again?
It is. Like again, I know this is equal to this, which means I know this is equal to this for this triangle, and this is equal to this for this triangle, but I don't know that this is equal to this.
I'd say circle theorems really did give me a headache back
It's
there.
it's missing
Back
like
in
one
math.
piece. It's missing one piece here.
Have you tried all 7 circle theorem rules?
Yeah, I'm sure there's another one I'm missing here. Let me think.
Maybe. What if you're missing like a parallelogram rule?
Well, let's see. One sec. This angle
remember-
here is gonna span. Yeah, I know you're talking about a parallelogram rule. What do you mean parallelogram rule?
Remember opposite sides in a parallelogram add up to 180? Like, you have to use your imagination, okay? That's what you gotta do.
Yeah, but I haven't created any parallelograms because I only know that this is parallel to this. I don't know any other of the sides which are parallel.
So, yeah, but you could make a parallelogram by connecting A to D. And then you could try to figure out one of the angles and then that'll help.
Sure, but I don't know that A to D is parallel to B to C. That's the issue. I don't know
Oh.
that those are parallel.
I really can't help out with this one.
It's okay. It's okay. We'll get it. We'll get it. We're gonna get it. Oh, I'm so close. So close. So close. Yes, the issue with these sides not being exactly equal. Although, yes, and I know those are the same because they span the same thing. What's up, Equity? Sorry, I'm a little stuck on this one. See, anyone in chat have an idea? I gotta get this last thing here. This last angle. If I can prove that this one is equal to all of them, then we're good. Okay. What if we make this as like a triangle? No. That has the same side, right? As... Let me see. That's like 3x plus that is equal to 180. And that's 3x plus that is 180. And then, is there a way to do something with this angle here somewhere? This 35 needs to be involved somehow, though. Unless I can prove that this is the center, and then I can just prove that's 90. That's what I really want to do. Oh, I'm so close. Don't look at me, I suck at math. Although I learned how to do chi-square and g-tests today. Cool, yeah, chi-squares are very useful. Incredibly useful. I do like chi-square tests. Chi-square tests are great. It's good for like comparing whether like two things are the same. One sec, let's see. What are we doing here, dude? Okay. This is equal to this, right? And this is the same within this triangle. I want to say that these two are the same, but I have to be able to prove that. Oh, wait a minute. If this isn't... Okay, well, this is another thing, right? If this is an angle bisector, and then this is 90, then I can prove that they're equal. So it's like a chicken or the egg thing is the problem. I either need to prove the two segments are equal or prove that this is 90. Fuck. Yeah, because what happens if I connect these two? Then I know this whole angle is equal to this whole angle. Oh, wait a minute. And then wait, this plus like mystery is equal to 180. This plus mystery is equal to 180, and then show that DB is parallel to AL. Right. If these are parallel, and this is a point. I don't know here. Not your friend. I'm stuck. I'm stuck at this point right here. If you can somehow show that yes, this angle is equal, then you can show that this is the center, then you can show this is 90, and then you can just show that this is 90 minus this. But this is the last part here. You need to prove somehow that this angle right here is the same as all the other ones. I don't see it right now. But yeah, that's good. Let me move on. Make sure we have time for everyone else's questions. But this was a good one. I liked it. It's close. I'll give things a little bit of a try, but then like you got to stare at it a little bit, honestly, for things to really like hit. Let me get this a little bit here. Yeah. Okay, cool. All right. Swaz posted a bunch as well. Patty posted a bunch. Oh, we got a lot of questions today. Okay. Nick, let me go through and make sure people who haven't gotten their questions answered yet first for the weekly stuff. Let me make sure we do that first. Swaz is not here. What's up with Patty? Okay, here, let me do Patty because I haven't done a question with Patty this week. And then we'll move up. Okay, Patty, what's up? Let me do your question real quick.
Yo, what up?
Yeah, nice. What's going on, dude? All right. Is this calculus? Are we doing calculus right now?
Yes.
Yes, we love calculus.
Separation of variables.
Okay. It's not too bad. All right. What you gotta do here is you gotta move all the y stuff on one place and all the x stuff on another place. Okay. Mm-hmm. So see how I have dx and dx on the bottom here, and I have dy on the top. Let's move this down here. Yeah. Let's move this up here. So I got dy over 1 minus y squared is equal to dx over x plus 1. Okay. Now you can integrate both sides, right? Okay. This one's a little tricky. Do you have to?
I just used u sub for.
You can use u.
Y.
Yes. Yes, you can do that. Yeah, you're right. Okay, yeah, right. So u is equal to 1 minus y. Du is equal to negative dy, right? Here I'm going to say that u is equal to x plus 1. Du is equal to dx, right? So this becomes the integral of negative 1 over u squared is equal to the integral of, and then this is, but these were the x's and y's.
1 over u. Du.
1 over u du. Okay, yeah, everything's du. Whatever. I'm being lazy with the du's. Okay, so raise this, right? Yeah, this is negative 1 over u, which is negative 1 over 1 minus y, right?
Yeah.
Good. And then this is going to be equal to the ln of x plus 1, right? And then we have a plus c somewhere. Okay, it can be on either side, doesn't really matter, right? And then what they say here is that when y equals 0, when x equals 0, y is equal to 5, okay? That's what y of 0 is equal to 5 means.
Mm-hmm.
Okay. So I'm just going to plug in x is equal to 0, and then I'm going to plug in y is equal to 5. So I get negative 1 over 1 minus 5, right, is equal to the ln of 1 plus c. What's the ln of 1?
Is that
should know this
0?
Yeah.
Yeah, good. This goes away. Bye. And so
okay, so when I did u sub, what I did was I set it the y side. I set it u equals 1 minus y. And then I got du equals negative dy, right?
Oh, sorry. There's another negative here. I fucked up. There's another negative here. Sorry.
Yeah, and then I put the negative out on the outside, so then just negative 1 technically, and then wait, why did I do that?
But no, it's okay.
U
so
squared, and I did ln 1 minus y. Okay, I don't know what I'm.
No, yeah, but u squared is u to the minus 2, right? So u to the minus 2 raised by 1 becomes negative 1 divided by the new negative 1. Sorry, I was missing a negative 1 there. It's always missing negative signs here and there. Okay, so then you get to here, right? For c, c is a quarter. So then you plug it into here. So now we got 1 over 1 minus y, with the positive now, is ln of x plus 1, right? Plus a quarter.
Yeah.
Which you could invert both sides, I guess, if you wanted to. Well, no, it actually kind of sucks to do that. This is just ugly is what this is. Because I gotta multiply this through by everything, dude, right? To solve for y equals. I think that's what they want, right?
Wait, hold on. So, is the constant 1/4 or negative 1/4?
Positive 1/4.
Okay.
Oh wait. No, it's negative. It's negative. I take that back.
Okay. Oh yeah, yeah.
Right, because 1 minus 5
Plug it
is
back
negative
into
4.
the original.
Mm-hmm.
So 1 minus y equals ln x plus 1 minus 1/4.
Yes.
Okay. I got that.
Okay. Now this is kind of ugly to deal with because in order to like
You like gotta get y by itself, yeah.
So I mean I could flip both
Right.
sides. I could be like, yo, just screw this, dude. I'm just gonna do this. 1 over y is equal to 1 over right? The ln of x plus 1 minus 1/4.
Yeah, I mean that's the lazy way to do it, but I mean
Right.
you get the same thing anyway.
And then you minus 1, right? Get rid of this. Well, this is a negative y, and then you flip the sign of it. You flip the a and the b thing. So it's y is equal to 1 minus 1 over ln of x plus 1 minus 1/4.
Okay, so y equals 1 minus 1 over 1 minus 1/4.
Yeah, I think that's what it is. It's kind of ugly, dude. That's like really gross, dude. I don't like that one. No.
I don't either.
No, God,
Yeah, dude,
please,
like,
no,
We got given an FRQ yesterday on separation of variables, and I did not enjoy that at all.
Yeah.
It wasn't for a test grade or anything, but like, struggled with that.
It struggles. It's not too bad though.
Let's see if that even works out, because Delta Math is, I think, the worst math software to ever exist.
Oh, use Wolfram, bro, dude. What? No, use Wolfram.
No, like for homework.
Oh, you have to
Like,
submit this.
that's
Oh, this
what
is like the platform you have to submit things on, dude.
Yeah.
Oh, that's
not
ugly,
Wolfram. Well, I use Wolfram sometimes if I need it, but
Disable stream mode. Who's typing on here? Oh, it's David Quantum Gravity. What's up, David Quantum Gravity?
let's see. Oh, and that was right.
It was right. Nice, dude.
Yeah.
We did it.
Yeah. I understand conceptually how to like separate the variables and stuff.
Yes.
It's just a matter of sometimes just the integration, like the.
Yeah, this was kind of tricky. I
sometimes.
mean,
And
like
then,
you saw.
especially when like there's ln or like e involved. It's like it's a whole mess.
It's a whole mess. Yeah. Yeah. I got a little spooked here at first, and I was like, oh shit, is this gonna be like arctangent or something?
I would hope that wouldn't be.
Oh, wait. David Quantum Gravity has a solution for this one. One sec. Let me see this one was what it says. Since AL is perpendicular to the circle, we know that LAB plus BAC has to be 90. Wait. How do we know that has to be 90? LAB plus BAC. How do I know that has to be 90 though, DC? What if this thing was like way over here? Like then I don't know that's 90. One sec. Yeah, why DC, why is that? Because a line is 180 and the perpendicular line that cuts it in half. One sec. Because a line is 180. Oh, yeah, well, okay. LAC has yeah, but wait, do I know that AC is the tangent line? I just know that AL is tangent. I don't know that AC necessarily hits it, right? I don't know that AC hits it there at the you know what I'm saying? Join DB and AC. AF should be a radius. I agree, it should be a radius, but you have to prove it. Since LAB plus BAC has to be 90, since AL is perpendicular to the circle. Yeah, the issue I have here is I don't know that AC is perpendicular to AL. I agree that A going through the center has to be perpendicular to AL, but I don't know that AC is specifically that. Here, let me like maybe put this up so it looks a little bit better. There you go. Oh wait, no, that's the wrong one. Sorry. Sorry, I'll get rid of that. Anyways, oh sorry, yeah. So Patty, does that answer your question? Is that good?
Yeah. It's just
Okay, cool.
like the process of going through it all.
Yeah.
I'm gonna
You
try
got
and
it.
work through some more problems.
Yeah, work through it. Post if you have any more questions. All right. Yeah, here. Yeah, here's the original diagram, DC. Yeah, cool. Yeah, DC. Yeah, the original diagram. Yeah, I drew this, and if this goes through the center, then yes, I agree. This is tangent. This has to be 90 degrees. Blah blah blah. But it's like, yeah, it's all the chicken and the eggs. We have all the chicken and the eggs. So many chicken and the eggs. And then wait, did I post the work so far? I did post the work so far. Here, so yeah, that's the work so far. Okay. All right. Here, let me while we get working on that one, let me see what the other questions we have. Teacup, are you here? Teacup hasn't asked a question. I know. Teacup was asking this. What was this? Let y of t be this solution. Let's see what this is. No, not this one. Nope. There we go. Sri Lankan questions are fucking hard, especially you guys get no calculators. Okay. Here, Teacup, where you at, Teacup? Where's Teacup? I'll wait for him. Oh, Teacup is here. Okay, good, nice. All right. All right, it says f of ty. Okay, so this is a function that's a function of t and y. Okay. And it says y of t be a solution of y prime is equal to f of t. Oh, wow. Satisfying that y of 2 is 3. Let h be 0.1 in the time step in Euler's method and set y0 equal to y2 equal to 3. What am I solving for? What is this? Page 555, he says. Okay, let's see. 555 in the PDF or the textbook? Can I just jump to a page, please? Oh man. There we go. 555. Maybe is this what it is? What's your question? What's your question, Jamarcus? Oh, you want Fourier transforms? You want to know about Fourier transforms? We need to get Rampton here to explain Fourier transform. Or actually, DC can probably honestly explain Fourier transforms. Yeah. David Chester knows a lot about Fourier transforms. For the research thing. I'll explain it to you, Jamarcus. Don't worry. Let me see, sorry, what Teacup's question was. Oh, yeah, see, Teacup, you got to post the whole question. You can't see there's multiple parts to this. Yeah. Yeah, there's a couple parts to this one, Teacup. Okay. Let point 1 be the time step in Euler's method. F of 2 comma 3. Calculate this. Calculate y1. Okay. So y1 is equal to... Oh, I see. And they're inching it up by 0.1. Okay. Okay, good. Good to see you, dude. Good to see you, dude. First of all, I gotta remember like what Euler's method is. Okay. Euler's method to approximate the solution with initial conditions is to fix a time step, set t k equal to t naught by kh using this formula. Okay. Okay, all right. He'll come back. Yes, but DC is correct with that. You can depose any into an infinite sum of sine and cosine frequencies. It's a very cool thing. There's probably a very cool graphic on it, DC. We could show them or something. What is it? Euler's method produces numerical approximations to the solution of a first-order initial value problem. Okay, by choosing a time step. And it says that the y value is equal to the y value before plus a time step difference times the derivative, which is a function of t and y. Okay, cool. Does he? Find me the link. DC, can you just post the link and I'll pull it up. I'm actually really cool. Yeah, I do like 3 blue 1 brown. Okay. So y1 is equal to y0. Do we know what y0 is? Oh, y0 is equal to y of 2, which is equal to 3. Okay, cool. So this is equal to 3 plus the time step, which is h. So that's going to be 0.1. And then it's times f of 2 comma 3. So let's remember that f of t comma y is equal to t squared minus y. So 2 comma 3 would be 2 squared minus 3. So that's 4 minus 3, which is equal to 1. So this just ends up equaling 1. Okay. Cool. So then this gets me a value of equal to 3.1. All right. I could then go another step. For instance, if I wanted to calculate y2. And y2 is taking the one before, y1. Which I guess is an approximation for y of 2. So this is like y of 2.1 maybe is what it is. Okay, nice. There we go. Yeah, cool. Thanks, DC. Yeah. So this is going to be 3.1 plus, now it's 0.1, but now it's f of 2.1, and then the y value we had before, which is 3.1. This is cool. This is iterative, is what it is. Right? So that's going to be 2.1 squared minus 3.1 squared. You know, I think we can actually do this in an Excel spreadsheet. This is pretty cool. Let me throw this in an Excel spreadsheet. I think this is cooler to do an Excel spreadsheet. Let's do new Google Sheet. Okay. Let's say this is we're going to say this is T, this is Y, and this is F. Okay. And then what was it? Whatever the y value is equal. Okay, and then we got to start off somewhere, right? So this was equal to y0. Or here, I'll just okay. Let's have y0 start at 10, just so I have like, you know, some sort of indices to it. I'm gonna say that is equal to 3, and in that case, what is? Oh, it's just y of something. Okay. Set y of 0 is 2 is equal to 3. Okay, cool. So then the next one here is equal. Okay, cool. And then this is 2 comma 3, right? 2, 3. Okay, so then this is equal to my previous value plus, and then it's going to be, the function is well, first of all, it's the difference, right, which is 0.1 times, and then it's going to be, I think it was t squared minus y. Yeah, it's the t squared. Yeah, that's going to be, it's this to the second, and then was it minus? T squared, yeah, minus this one. Okay, cool. What? Why can't you figure that out? Yes, you can. Invalid call to non-function. Or do you want me to do this? Do I have to just say it's times B10 again? It's dumb. Why does that work? Equals A10, right? This. Oh, can you not put parentheses? Maybe that's what you have to do. There we go. Okay, cool. And then this is always going to equal this one plus 0.1. Or let's have this. Okay, and then we should say what the h is. Sorry. I'm going to say it's plus this. And we're going to have this is h, and then this is equal to 0.1. And then let's have this equal to this, but I forget how I freeze it. I think I freeze it with this. Do I put a $sign there? No. I think it's, maybe that's how I freeze it. Yeah. Okay, cool. And then this, and that's y1. Wait. Yeah. Okay, cool. Now watch what happens here. This is actually pretty cool. I think that's what this is, right, DC? Oh, wow, that's a 20-minute visualization. Best of luck. Thanks, DC. I appreciate that, dude. I got a French test tomorrow. Not feeling good about it. What's wrong with French? What's wrong with French, dude? You'll be fine in French, dude. What? Wait, why is it not adding it, though? It should be adding it. B11 plus... Oh, sorry. I gotta change this. Sorry, this has to be... I don't think this can change. Sorry, let me get rid of that. Don't need that. Yes. This is just whatever the T value is. This has to change. Yeah. There we go. No. Yeah, wait, what? Oh, sorry, you gotta put a $sign here. There we go. Okay, that looks better. Okay. That's cool. I don't know what this really shows you, but yeah.
That's dope.
Good job, Teacup. I don't know. You're getting a little bit advanced for like slope fields. I don't think you actually know what this stuff is, but it's okay. We'll count it. Teacup, let's try. I'm gonna give you something like next time that's earlier that you can like actually understand, because I don't think you have to understand like what slope fields are for this to work. Or I'm gonna say like, you know, find something a little bit earlier. Okay. All right. Let's see. Bob Rosa says, when tech companies write off expenses and act like they lost money, but the public knows that they didn't, then why doesn't the government do it, or is it an investigation? Well, I mean, technically they did lose money. It's just, but they lost money putting more money into themselves, you know? They're just constantly reinvesting. If you're constantly reinvesting in yourself, then it's seen as like, quote unquote, losing money. Yeah. It's because it's legal. That's how it is. And the government wants companies to reinvest in themselves. So that's why they give them the tax breaks for that. If people donate to us, for instance, as a nonprofit, they don't pay that on their taxes. Like the money they give to us gets counted against their income. It's the same. The government just does things to try to encourage certain things to happen. I agree that corporations probably have like some excessive loopholes into what they can count as a loss. It's actually the whole trick with how Trump, I don't think, paid taxes for like 10 or 12 years, is he kept writing off like some massive loss on a property over and over, like a whole decade. And so then you're like, oh, I'm not paying taxes on my next income. Yeah. The IRS gets their money. Don't worry. The IRS gets their money. Yeah. Okay, let's see. Okay, Nick, what is your question here, dude? What is this, dog? Nick, you gotta give me what the poem is first. Like what? Okay. Here. Well, yeah. Post what the poem is, Nick. I need to see what the poem is. All right, Taco, are you here? You want to learn some chemistry? This is actually pretty useful. What's up, Taco Cat? Where you at? Nice, cool. All right. Do you know what these words mean here, Taco Cat? Do you know what this means? Like oh, well, they say it here, actually. That's nice for them. Combustion, synthesis, decomposition, single replacement, double replacement. Yeah. They're kind of tell you what there's some qualities to like what these different types of reactions are. Do you know like what happens in a combustion reaction? Combustion is like lighting things on fire, which is pretty cool. I know, I love to light shit on fire when I was your age. That's why I joined Boy Scouts, was really just to be able to like create fires. But yeah, this is how a combustion reaction works. Let's get an image from it. That's kind of cool. No. Dude, what? Where's that image, dude? Can I please have the image? Copy image. There we go. Thank you. Yeah. So in a combustion reaction, Monkey, you have a hydrocarbon plus oxygen that reacts together to form CO2, water, and then heat and light. Okay. So in the reaction here, we know that we have to produce CO2 plus water. Okay. That's what I know has to be the products of this reaction. Okay. Now, the next thing they're asking you to do is to balance the equations. Do you know how to balance equations? It's a very useful thing to know how to do. Where's my screenshot, please? Can I have my screenshot? Thank you. No? Dude, snipping tool. Let's work today. No, where are you at? There you are. Are you on a different screen? Oh, there you are. Okay, one sec. There we go. New snip. There we go. That's what I want. Copy. You know how to do? Okay. So how would I balance this? Here, I'll show it for everyone else. Okay. So what happens is you always write out like the things you have on each side. So here I have carbon, I have hydrogen, I have oxygen. Here, and then you're going to have the same things on the other side, carbon, hydrogen, and oxygen. And then I count how many I have of each. So right here I have 3 of these, I have 6 of these, and I have 3 of these, right? Because I got 1 oxygen here and 2 oxygens here. Here I have 1 of these, I have 2 of these, and I have 3 of these. Oh shit, I was doing the right. No, you got to balance both. So you need the numbers to be the same, okay? So what I always like to do is go for the most complicated thing first, which in this case is the C3H6O, and try to balance that thing. And don't worry about hydrogens and oxygens until later. Hydrogens and oxygens you can worry till last. Yeah. So yeah, I would probably put a 3 on here, right? Because I need 3 carbons here to balance with 3 carbons here. Okay? But when I do that, isn't carbon 2? No, because this is C3H6. On the right, isn't carbon 2? No, it's just CO2. Sorry, the 2 only refers to the oxygen. There's CO2 carbon dioxide, so it's a single carbon and 2 oxygens. Do you see that? Yeah? Okay. So if I put a 3 here, right? Now this turns into 3, and now my oxygens is 6. This is going to be 7, right? So now this is getting a little weird, right? We're like, uh-oh. But at least my carbons are balanced. Okay. The next thing I can then try to do is to balance my hydrogens. Okay. So I see I have 6 hydrogens here, and I don't really want to put a number in front of here because then that would screw up the number of carbons because they're entangled. They're right next to each other. So I want to try to just like make the number of hydrogens here equal the ones here. And the way to do that, right, would be to put a 3 on this as well. Okay? Because see, now I'm going to have 6 hydrogens, which is nice. Why is oxygen 7 on the right? Okay. Because at this point in time, Monkey, I have 3 times 2, so I have 6 oxygens from here. And then before I did this, I had only 1 oxygen from here, which made it 7. Okay? But now, since I put in a 3 in front of the hydrogen to make this 6, okay? Because this went now from 2 to 6. Now I've also changed the number of oxygens as well. So now I have 6, and I have 3 from here, so now I have 9. Okay? Does that make sense so far? Monkey? It's okay. It's okay. I can go over it again. Does it make sense, though? Does it make sense once we're at this point, I have carbons balanced, I have hydrogens balanced? Because the next part's tricky. The next part's pretty tricky here. Okay. The last thing I need to do is I need to balance the oxygens, okay? I need to balance these. Yeah, you didn't see it? Yeah, you got to count up for all oxygens, yeah. So, I need 9, right? I have 3 so far. I don't want to touch this again, right? I don't want to put numbers in front of this because that will screw up my carbons and hydrogens that I've already balanced. Luckily, O2 is by itself, so I can target that thing by itself to try and bounce the oxygens. And so what I can do here is I can put a, let's see, we want to get to 9. I have 1 from here, so I would like to have 8 from here. So what number am I going to put in front of the O2? Multiply by 4. Yeah, exactly. So now I put a 4 in front of there, right? And now this turns to 9. Yes, and then you're good.
That's dope.
Yes. So yeah, that's your balanced reaction.
Well done. Well done.
It's a cool. I like this stuff too. I think it's very cool. Yeah. Who was that? That was Taco Cat. Taco Cat. Yeah, all these ones are great, dude. I love these, like decomposition, double replace. This is double replacement's a very cool reaction. Single replacement is like where this switches with this, and that you have to know about like ionic charges and stuff. Yeah, ask me more questions about these next time. This is great. If you want to go through this and have me teach you how all of these reactions work, there's a lot of like different chemistry topics in here that are useful to learn. So yeah, this is very good. Just keep reposting this picture. Okay. Let's see. Ethan, what's up? You here? Or wait, Nick actually posted. Sorry, my bad. Sorry, Nick. Sorry. What did you post? You posted the okay, this is the poem we gotta learn. Oh god, dude, what? You want me to read all of this, dude? Like, excuse me? What? What? This is such a long poem, dude. I can't read this on a stream. Oh, man. No, Nick. Nick. What are we going to do with you, dude? Because this is your question. Says, what social issues are discussed in the poem? Are they still relevant today? What is... Okay, whatever. Are they relevant today? Okay, homelessness, education. Who is an obligation to family or society? Okay. The last part, she's asking about, like, in today's society, like, what do we have going on with homelessness, right? You could say that there's a lot of it, right? A lot. It, affects the mentally ill pretty badly. Things with education. Well, that's what my whole Discord here is about. I've got a math poem. A dozen, a gross, and a score, plus 3 times the square root of 4, all divided by 7 plus 9 times 11 is 9 squared, and not a bit more. That's a good one, Zach, dude. I love that. It equals 9. Yeah. Well, 9 squared. It equals 9 squared. That's the poem, yeah. But, okay. If they're talking about education, right? A big thing that I kind of harp on here is that there's kind of like an inequality in education between, we would say, like wealth classes. Okay. So, for instance, in order for me to pay my rent, I have to charge a significant amount of money to help people privately. I help you guys for free. This is free. But to the other people I meet with one-on-one, I have to charge. And unfortunately, that means that kids who can't afford me can't get my help. But those that are wealthy can. So that's something that, is probably still prevalent today. Shows up in the poem. And then obligation to family or society. Yeah, I mean, you could talk about this. Are they relevant today? I would argue that today, most people don't really feel like they have an obligation to family or society. Unfortunately, I do. I definitely feel like I do. But I think in today's world, there's a lot of like selfishness, and you especially saw this during the pandemic, when people were like hoarding toilet paper. Like people are just like showing up and just like buying like 9, like they're just buying out all the toilet paper, buying out all the tuna fish. Just like what? Like don't do that, dude. I didn't do this. But that type of behavior is very selfish. It's like, I don't care about society, right? Exactly. Yeah. So I don't know. I'd have to read what this poem is, which it's the death of a hired man. I don't know. This is a very long poem. I'm not going to read this on the stream. This would take So it'd take way too long. If someone wants to read it, you know, it's here. You got to look for like what similar themes are there. So let me just try to pick one out for you if I could just see it just quickly. Here we go. Here it says Silas had walked that far, no doubt, today. Why didn't he go there? His brother's rich. As somebody in the bank, he never told us that. We know it though. I think it's brought out to help. So here, this part of the poem is talking about, you know, if one of your siblings is rich, they should have a family obligation to help you out as well. Right? So you could maybe talk about that in today's society, right? You know, if I know you don't have any siblings, Nick, but I have siblings. I have 5 sisters. But if I had a lot of money and my sisters needed help, I would definitely give them money. So that's kind of what they're going through here. They're going through like, do siblings feel a responsibility that they should help each other if one is like richer than the other? Near they say, poor Silas, so concerned for other folk, nothing to look backward, nothing to look forward with hope. I don't know, this is interesting. I don't know, this guy is apparently selfless but like hopeless. Robert Frost did tend to be kind of like depressing with his stuff. This is kind of depressing. Let me see. You gotta have something with like, here we go. The boy you've been haying 4 years since he's finished school and teaching in his college. You'll have to get him back. He says they will make a team for work between them. Okay, yes. On education, you know how they fought. Yeah. I think there's something here with people. Again, this is kind of a wealth inequality thing here. I think this is talking about like this guy Silas had to work on a farm where Wilson got to go to college, and so that's another aspect. Read the poem? No, dude. maybe I'll maybe on like one of the AMAs or something. I'll read this to you. It's like, was it like story time? But I mean, that's another concept that, again, I was talking about with education, right? That only really the wealthy can afford like good education. So yeah, only you could say in today's society, college tuition is so high, right? That most people don't have enough money to go to college, so they have to go work, you know, another job doesn't really require an education, you know, work in the fields or something, as it was going here. Yeah. Silas, now terminally ill, seeks refuge on the farm where he once worked. Mary pities him while Warren is reluctant to give him another chance. Class and compassion. Yeah, these are all big things that are happening in today's society, right? We have a big wealth gap inequality thing, right? The rich get richer, the poor get poorer. It sucks. And yeah, there's a lack of compassion for each side between the two. Yeah. So talk about that. That's like a modern day thing, I would say that's happening. Yeah. Okay. Good question, Nick. I'll give it to you. Yeah, class and compassion. Yeah. Legacy and belonging. These are all things. Yeah, right. Human need for belonging. The human need for like purpose, right? It's like, why do we exist here? If like, what are we doing? You know, there has to be a reason. I say like a legacy that you're leaving. Yeah, it's good you guys have the internet and everything. You just literally Google like what these poems are about. I go to like try to read this, and I don't know. It would take me a couple tries. I'd have to read this a couple times because the English they use is kind of like old and convoluted.
You about to go?
Yeah, Ethan, let's do your question. You ready?
Yeah.
Cool.
Although I wanted to tell you before about with Patty G, I actually asked a calculus question.
Okay. What'd you ask?
Calculus.
This is a calculus. This is a calculus question.
Yeah.
I made it read it to me. What? No, you need to learn how to. You need to learn how to read. No, Nick, you need to know how to read.
No, God.
Please, Nick, your spelling is not the best. We need you to read. The only way to get better at your spelling is to read. You know, my dad made me read like a book every month when I was your age, and I wasn't allowed to like play on the computer if I didn't have like a book read. So y'all should read more. Can you send me the pic of? Yeah, one sec. He wants me to send me this picture. Okay, here, and then let me do this. What was I writing? I was writing like selfishness. You can talk about COVID. Talk about COVID. Talk about like hoarding. That was definitely a modern day thing that happened recently. I kind of lost, I don't know, hope for society when I started seeing that. I was like, what's going on here? Why are we hoarding toilet paper? We all lost our minds. I love reading, but not for homework. Okay. Well, yeah. Sometimes you got to read stuff that you don't want to read. It's okay. Okay. All right, Ethan, what's up? Okay, this is cool. The town of Plainsfield is 4 miles east and 6 miles north of Burlington. Ooh, I used to live in Burlington. It's in Vermont.
Dang, okay.
Yeah, I used to live in Burlington when I was very young. Okay. Well, okay. So we got to like start drawing some points on things, right? I gotta pick one of these things to be the origin.
Could you tell me the basics?
That's what we're gonna do. Okay, I'm gonna define that Burlington is at 0, 0. Okay.
I mean, that's where the origin is at all times.
Yeah, but then so if Plainfield is 4 miles east and 6 miles north, what point is that at? Where's Plainfield?
4 miles. Wait, 4 miles east and 4 miles north?
6 miles north.
Isn't it?
This is actually called like heading, is what this is called. It's kind of interesting.
Yeah. Isn't it just at the right top?
Good, right top. Yeah. So this means 4 over to the right and 6 up. Okay. So this is going to be probably here, right? This is going to be Plainfield, which we're going to say is 4, 6. All right. Allentown is 8 miles west and 1 mile north of Plaintown. Okay. So where's Allentown then?
Wait, hold on. What? Could you say that again?
Well, just read it. Read it, Ethan. Allentown is what?
8 miles west.
Mm-hmm.
And 1 north of
Good.
Plainfield. So it should be at the left top. Somewhere at the left top.
Right. So it's going to go over 8, right? And it's going to go up 1, right? So that's going to bring us... What's up?
Why would you do that? I thought you would make a new point.
I'm going to make a new point. I'm going to say it's -4, 7.
I thought you were going to go on the x-axis and then go to the y-axis and make a complete different point. Why would you continue with that other one?
Okay, because they said Allentown was a certain distance away from Plainfield. They said it was away from here, not from here.
Okay.
You get that? It's a relative distance is what it is. So they tell me, for instance, Plainfield is this far away from Burlington, right? But then Allentown is this far away from Plainfield. Okay?
Okay.
Good. And then a straight road passes through Plainfield and Burlington. Okay, so here's our road. So let's imagine our road. We got a road. It's going right here. Okay. A second straight road passes through Allentown and intersects the first road at a point somewhere south and west of Burlington. Oh, okay. A straight road passes through Plainfield. Okay, oh. So they're saying this actually passes through kind of indefinitely. They say it does this. Okay. And then they're saying we have a second road that passes through Allentown and intersects the first road at a point somewhere south and west of Burlington. So that's got to intersect, right? Somewhere over here. But we don't know yet, right?
Okay.
The angle at which the roads intersect is pi over 4. Okay, this is cool. They tell me that...
0.78.
Yeah, they say that...
Like, that's what it is.
Well, pi over 4, let's remember... Do you know how many degrees that is? Because pi over 4 in radians is kind of weird.
Wait, my calculator is in degrees mode.
Yeah, but just plugging in pi divided by 4 isn't going to tell you the conversion to degrees. You have to do this. You have to do pi over 4. No, times 180 over pi. This is the conversion from radians to degrees.
All right.
Okay. This gets you 45 degrees. Okay.
How do you know that?
Because 180 divided by 4 is 45.
All right.
Does that make sense?
Yeah.
Okay. Okay. So now we need
45 before in radians.
Sorry, what?
I did say 45 before in radians.
No, it's not 45 radians. It's 45 degrees.
Oh, well, yeah, that's what I meant. Like 45 degrees in the radians mode.
Oh, yeah, good. That's 45 degrees in radians. Yeah, you're right. Okay. Okay. So we need to figure out the point of intersection. That's kind of cool. So they want us to figure out this. It's actually a cool question. I like this one, Ethan. It's a good one. Okay.
It is calculus after all.
I guess it is calculus. I mean, we're not really going to do any derivatives here, but okay. Okay. Here's what we're going to do here, Ethan, okay? I'm going to describe 2 vectors, okay? I know vectors is kind of a scary word. But the
eigenvectors.
No, they're not eigenvectors. We're not doing that.
What are eigenvectors? Are they scarier than vectors?
They are scarier than vectors, yes. Eigenvectors are special vectors.
What eigen?
Yeah. Noise says, vectors. Gaming. Welcome, gamers, dude. What's up, Noise? I miss you, dude. What's up, Noise? Noise in the chat, dude. Hi, chat. Eigenvectors.
I wanted
What's
to
up?
ask. So you're actually gonna do a 3,000 NT giveaway for a partner stream?
It's not a giveaway. It's a challenge. It's a challenge. So yes. Okay. So yeah. Because I know some people here don't know about this new challenge for the tournament.
You can do that weekly as well.
And you can do the weekly. So it's a bonus. Okay. So where did I put this in the? I put this in the announcements here. I think I did. Okay. Yeah. Cool. So in the announcements,
I did put it in the.
Okay. Yeah. So for today. Good for always read here. This is always where I announce things. So for this week, right? Because I know that like we're running out of time when I'm trying to go through everyone's questions. I've talked to a lot of the other math streamers on Twitch, and they've been really nice and agreed to answer some of y'all's questions for credit. So what we're doing is that now you can also ask a math question with the other math streamers. So usually this will just count towards your weekly credit, so you don't have to do it here. But I'm also offering a one-time bonus, so you can only do this once over the tournament for now, at least. I may make it more times, where I'll give a one-time bonus of 3,000 if you ask for help on one of the partner streams. Let's see. Equity's asking. He said, "What's up?"
You see, how can we? Yeah, that's the same question I'm gonna ask. How can we post the questions?
Well, here we go. So watch. So here, I'll explain. Okay. So again, to claim your credit, just go to one of the streamers and get help. So, and again, here's if you use !partner schedule, that will show the schedule of all the other streamers that are doing math. And then these are their links, okay? In addition, if you want to know when they're streaming, because they don't stream at these times all the time, like sometimes they're not exact, is if you go into the office hours stream here, it will tell you when they're streaming. So for instance, this is when Dawn was streaming. There was a notification, and then I think, well, maybe I just enabled this today. But when Zach streams and whatnot, it'll come up. So yeah, that's a way to get help.
I'm pretty worried for this.
Why are you worried about this? It's very easy.
Because I really do not know how I can get this weekly credit for once.
You already got the weekly credit. No. You already got the weekly credit. This is like a one-time credit over the whole tournament. It's a bonus.
No, but I want this one as well. I need
Okay.
I need this.
Oh, okay, that's Patty's. Okay, cool. Yeah, thanks. Yeah, no, it's easy. You just go onto one of their streams. You ask a question. Ask a good question, please. Don't bother them with like. I know some of you kids ask like troll questions here. Don't do that to them, please. Like, ask them a legit question you need help with. And when you do, okay, what you do is then you go over to their stream. Where it happened. So here's an example. If I went to, let's see who else is who has been streaming today. Dawn is streaming right now, which is cool. See, I think Don is doing stuff. Yeah, he's see Don is answering math questions right now is what he's doing. But if we go to where's his channel? Sorry. Does he have his channel? Yeah. Okay, so if you go to videos here, these are called the VODs, right? Which these are recordings of all the streams he's done. So you just have to go to here, go to a stream that you asked your question, and then you just create a clip of you getting your question asked. Create a clip? I'll show you. I gotta wait for this advertisement to break. But okay. Anyways, so for instance, let's say like here I was getting my question answered, or I don't know, like here. Let's say here I was getting my question answered. Then what I would do here, right, is I would create a clip.
Like a screenshot?
You can create a screenshot if you want, but you should also wait. Does Don not? Oh no, here. Do you see here where it says clip? See where it says clip? It says clip. Clip right here. It says clip Alt X. If you click on this,
yeah, just
it'll then enable you to create a clip on their stream, which is like a recording of what happened.
Well.
And then you can just title this. Title this as your username or something. Be like, Ethan getting help.
No.
And then you publish it, and then it'll give you a link for that clip, and then you post that link in the Discord.
Which channel?
What can we do?
I say it in the it's in the read the directions. It's in the directions, guys. It's there.
No.
Wait, empty leaderboards?
I think it's called empty scoreboard. Yes. What's up, Obama?
Yeah, empty scoreboard.
Hello.
Hello.
Yo, who redeemed? How much points did who are the top two? Ethan and someone else?
I think Ethan redeemed like 5,500. Yeah, earlier.
Holy.
Yeah.
Okay,
wait, that's all?
Yeah. Ethan, here, let's do this one. What's up, QV?
Oh, he's definitely waiting.
Here, let me finish Ethan's question so then I can do QV's, and then I'll do some more with Patty. Cool. Also, Patty, I think Noise says he already solved your question. Good. No. Oh, Patty was before Ethan. Just posted the same question twice. No. He posted 2 different questions, I think. He posted 2 different questions.
Yeah.
True. Noise, you're okay. He posted 2 different ones. Okay, Ethan. So, here's what happens. I'm going to create a vector. A vector is like an arrow which points from a starting position to an ending position, okay? It's like a direction thingy, okay? It's kind of like what I like to describe it as, direction thing. And we have 2 vectors here, all right? Let's call this vector A, and let's call this vector B. Okay? All right. What I know is that the dot product of these 2 vectors, okay, so A dotted with B, which is like a fancy way of multiplying vectors together, is equal to the magnitude of A times the magnitude of B times the cosine of the angle. Yes, magnitude is the length. It's the length of it. It's just how long the vector is. And then it's times the cosine of the angle in between the 2.
Okay.
Okay. We're going to get how these things work, okay? So, let's call this this is some mystery point, right? I don't know where this intersection is, right? This intersection is at some, let's just say x comma y. Okay? We got to solve for where this is. If I want to describe what a vector is, okay, in terms of what we say like is brackets like this, you have to do the starting point, you have to do the ending point minus the starting point, okay? So let's say vector A here. So vector A is going to equal this minus 4 comma 7 subtracted from x comma y, okay? Do you see how I'm just taking like 2 points, like whatever this point is and whatever this point is, and I'm subtracting the 2?
Yeah.
That's going to give me this. It's going to give me this in component form. So this is going to be minus 4 minus x, comma, 7 plus y. Okay?
Wait,
so
why is there one with minus and one with plus?
Good. Because it's this point minus this point, but the minus distributes on both things. Okay? So here I have minus 4 minus x, and then I have comma 7 minus minus, so that's plus y. Okay?
Alright.
This is the component form for the vector of this. Okay, that does this. All right.
All right.
Now, for the other vector here, let's say vector B, right? I need another 2 points, but that's going to describe which this one is, all right? So here, I know, right, that this vector has to be equal to this one minus this one. Okay, so let's say it's equal to 0, 0, right? Minus, what is that going to be? X minus Y.
Minus Y.
Mm-hmm. Okay.
Alright. And then that wouldn't that just be like wouldn't that just be like 0 plus 0 comma
So it's 0 minus X. So that's going to be negative X, right? Comma.
alright.
And then this is going to be negative
that
Y.
doesn't make sense. Because you would think that there's an imaginary number there, 1. You would think that there's a 1 there.
No, you just think there's a 0. It's 0 minus X, which is negative X. 0 minus, 0 minus minus, which is plus Y. Yeah, you're welcome, Nick.
You're done.
Okay. Okay. So now I could dot product these two things together, right? Okay.
Alright.
And what happens when you do a dot product is you add these components, and then you multiply these components, and then you multiply these components, and then you add them together. That's what you do.
So isn't it gonna be like 4 2x comma 7 plus 2y?
So it's gonna be minus 4 minus X all times minus X plus, see how I'm doing this one times this one? Plus 7 plus Y times Y. Okay? That's A dot B. That's what that's equal to.
Okay.
Okay? And then, okay, this is where things get tricky. The magnitude of A, the magnitude of B. If you ever want to, if we have a vector, which is, let's just is like 3 comma 4, all right? The magnitude, let's say this is like a vector X or vector C. The magnitude of vector C, which is the length of vector C, is the Pythagorean theorem, which is going to be the square root of 3 squared plus 4 squared, which ends up just equaling 5.
Okay, Dr. Go, this is too much now.
I know. Well, you asked a question that has like a lot of complicated parts to it. The magnitude of C is the square root of the X component squared plus the Y component squared. That's what it is.
Alright.
Okay. So when we're doing this, right, the magnitude of A is going to equal the square root, and then this is going to be minus 4 minus X squared plus 7 plus Y squared. Okay?
Alright.
And the magnitude of B is going to be the square root of just negative X squared, which is just X squared, plus Y squared. Okay?
Okay.
So then that's what this is. That's what this is, right? Oh, this is going to be kind of messy, honestly.
Yep, I agree. I definitely agree.
Yes, it is. Well, there's another trick we can use. I'll show you. So it's this times this.
No, please no. Please.
And then it's the cosine of theta. And theta is 45 degrees. So that's just going to be square root of 2 over 2.
You use square root. You use square roots? Why?
Yeah, because that's what the cosine of 45 degrees is. Square root of 2 over 2.
The square root of 2. The cosine of 45.
Square root of 2 over 2.
Oh my goodness, this is ridiculous.
Okay. The other bit of information that we get to use, okay, because, I mean, this is technically close to being solvable because it's an equation. The problem is that it has 2 variables. So you see I have x's and I have y's. That means I technically need 2 equations. Okay?
Okay.
So the other equation I can do is I know that, like, this part, right, this vector B, has to have the same slope as going from B to P. Right? It has to have the same slope as this one. Because you see how they're all on the same line?
Okay.
Right? So, if we found the slope between these two things, right? That would be, let's say, y minus y. So that's negative y, because it's 0 minus y over x minus x. 0 minus x. Okay? So negative y over x is equal to this slope between these 2 points, right? Which is going to be 6 over 4, right? Because it's 6 minus 0, y minus y, over x minus x, 4 minus 0. So that's equal to 3/2.
Yeah.
Okay? So this gives me a little bit of a solution here. Because now I can say that, okay, cool. This means that y is equal to negative 3/2 x. Okay?
Okay.
Which I would now need to plug into here. So this is negative 3/2 x. It gets plugged into everywhere.
This is ugly.
It's very ugly. And then you could solve it technically. I don't know that I want to solve it right now because that would take a lot of time. But this is how you do it.
Okay.
Someone in the chat tell me if there's an easier way to do this. I know that this way will work. I'm just curious if there's an easier way that this works. I mean, yeah, this is how I find the location. Carrying out the computation is unfortunately kind of messy. It's you have to do all this, which I don't really want to do right now. So, let me do QV's question, and then we'll count. This is a good attempt. Yeah. Cool. All right. Good job.
Also, I go. What happens if I'm getting so much coins right now. What are you gonna do if I have so much?
I'll probably give out another prize. Let me see. I got a lot of things going on, Ethan. Don't worry. Keep earning. They're always worth stuff. They're always worth stuff.
Yeah. What is the max coins I could get for another prize? Like 500?
You can get as many as you want, dude. The more coins you get, the bigger the prize I'll give you.
Well, it looks like. What happens if I earn up to 1,000 then?
Maybe I buy you a laptop or something. I don't know. We'll see.
No. I want a PS5. I want that PS5.
Yes, I want the PS5.
And
Did
how
the
much
second
money
part
do we
of QV's question in office hours. Thank you, dude. Appreciate that. Yeah, QV. Wait, what are you doing? I don't know yet, Ethan. I'll tell you. I'll tell you when I do it. Don't worry. I know you guys need goals now. I get it, but I gotta figure out a lot of stuff first. I gotta pay rent this month. QV, what's going on, dude? This is a little advanced for you, bro. QV, what the fuck? This is like calculus, no? Is it?
Yeah, I missed the day.
Okay, did you miss like 6 weeks? That's a lot. This is very different.
No, I just...
Oh wait, I was helping you with chemistry last time, right? Is that what I was helping you with, Chem?
Yeah.
Oh, okay, never mind. All right, cool. Okay, the twice differentiable functions are given for all real numbers, blah, blah, blah. Cool. Evaluate this. F prime of g of x, g prime of x. Oh, okay. That's cool. Hint, let u equal g of x. What is this? Noise said he did the second part of your question. Let me see what he did real quick. I appreciate you, Noise. Just like Noise just in the background, just like going through the questions while I don't. Where did he do it? Okay, you did that one. Okay, cool. I like that. Cute. Yeah, that's great. Okay, we can do that one later. Okay. Let u is equal to g of x. Okay, so u is equal to g of x, right? All right, awesome, cool. And then what is du going to be equal to then? It's equal to g prime of x dx, right?
Yeah, that sounds right.
Does that sound right? Yeah, right. If I take the derivative of this is a chain rule is what this is, right? It's g prime times whatever the derivative of what's inside, which is dx. Okay. I read it and I thought, no. All right, well, we're going to learn here. We're going to learn. Okay. So if we do this, right, then I can probably like flip some shit around here. Okay, cool. So this is -2 to 3. And then this is f prime. So that's f prime of g of x. So that's f prime of u, right? And now this is the cool thing. Look at this. G prime of x dx. Do you see how that's right here?
Yeah.
That's just du.
Yeah.
Right? On Valentine's Day, yes. Oh, it is Valentine's Day for Noise. Yeah, it's UK time. Okay. This is the fundamental theorem of calculus. Do you know this when you take the integral of a derivative? Do you know what happens?
You get the original function.
You get the original function, but then you need to evaluate it at this.
Oh, so
okay?
it's f of b minus f of a, right?
Good. Yes. This is f of b minus f of a. Okay. Yeah, exactly. But there's some trickiness here. All right. Because this is saying that you have to plug in for u, you have to plug in 3. Okay. So what you're doing is, so f of b here is like f of u is equal to 3 minus f of u is equal to -2. Okay. And then we have to remember, like,
you have to change the
the bounds.
And end.
Yes, I would need to. I would need to change the bounds. So I could do that. Well, problem is, like, these things are in terms of dx, and this is in terms of g. Well, okay, so we'd be converting from. We're gonna do the same thing. Here, we'll do it both ways. We'll do it both ways. Okay, let's do it trying to just convert the bounds. Okay, so everything's termed. When we started this integral, right? -2 was equal to, like, x. That was like an x coordinate, right? But now I've gotten to doing things in terms of u. So I need to know what was the conversion to get to u, right? So if x is equal to -2, and then u, right, is equal to g of x, that means u is going to be equal to g of -2. Right?
Yeah.
Okay. And u is, so g of -2 is equal to -1. So now this bound is -1, okay? So when x equals -2, u equals -1. And then the other one was 3, right? So when x is equal to 3, so u was equal to g of 3, which is, what is that? G of 3 was 1, right? Is that 1? Yes.
Yeah, 1.
Good. Okay, cool. Okay. So now when I do my evaluation, right? So we could have done this. So this would be f of b minus f of a. So now if I do the integral, this is no longer -2 to 3, right? This is going from -1 to 1 of f prime of u du, which is going to be, right, f of 1 minus f of -1. Which, okay, from here, right, f of 1 is 2, f of -1 is 8. So this is 2 minus 8, which is equal to -6. Okay?
Okay.
Does that make sense? And I hear your voice. You're just like, the fuck, dog? What the fuck is this? What was it? The other one was like, u is equal to 3, u is g of x. G of x is equal to 3, so watch, this is actually kind of cool. It does kind of like the same thing. So this is like f of 1 minus f of, when u is -2, and then g of -2 is -1, f of -1. Yeah, it's the same thing. f of 1 minus f of -1. You get the same answer. So you can do two things here, QV. I tend to not move the bounds until the very end, is what I do. So I'll just ignore what these are, and I'll just start, like, doing stuff. And then when I get down to here, when I'm doing this, I'm like, okay, cool, but this thing now has to be termed in terms of u. So they originally were in terms of g. Well, actually, they were originally in terms of x, is what they were in terms of. It's like a double thing you have to go over. Oh, this is fucking annoying. One sec. Let me think. Okay. I think the better to not confuse you. I think the better way is to change the bounds right when you get here. So, like, don't do this stuff. I think this is too confusing because you're having to double up back over stuff. Okay. Let's think of it this way. Okay. So when you do your change of variables, QV, from u is equal to g of x, du is g prime x dx, and now you have, do you see how you have f prime of u du? Now you need to look at like, okay, well, my original integral was all in terms of x's, okay? Do we see that?
Yeah.
Okay. I now need stuff to be in terms of u's, okay? But u is equal to g of x, okay? Because that's the substitution we made, okay? So here, I can say like, okay, cool. u1, right, which is my top bound here, is equal to g of the top bound, right? G of like, let's say like, let's call this, for instance, this is x1 and this is x0, right? The starting x and the finishing x. This is the starting u and the finishing u. I know the finishing u is equal to g of the finishing x. And that's why it was g of 3, which was equal to 1 from here. Does that make sense? No?
Yeah, I think that makes more sense now.
Okay, then what is u0 then? So what's my new bound on the bottom?
G of x0.
Right, good, which is what?
G of -2.
Good. Which then, right from the table here, g of -2 is -1. Okay? So now your bounds are correct. Because now if I say, okay, from -1 to 1, f prime of u du, now these are like technically in like u land, right? They're in like u space. And so, yes, when I do this, this is just f of the top bound, f of 1, minus f of the bottom bound, -1. And then these, you have to look up again. You have to look up, okay, what's f of 1? It's 2. What's f of -1? It's 8. And so no, that's why it's 2 minus 8, which is equal to -6. Yeah. Do you see that? Do you see that last step here?
Yeah, I get that.
Okay. Cool. I wonder how many people I can work with can do 2 minus 8. I don't know. In my computation for 6, I changed the limit straight off the bat. I agree. Probably should have. Okay. Yeah, so this one's -6. Cool?
Yeah, thank you.
And then did this one make sense?
No, that was the one I was like more confused on, because
Oh.
I'm not really like sure like how you change like the integral. Like how do you rewrite that in terms of du?
Okay, let's look at what Noise did. So Noise is a very helpful person in our server. He helps a lot with stuff. So I'm rather than me rewrite everything, let's just go through what he did for his work, and then I can explain it to you. Okay. So this was the original integral, right? So what he noticed is that something on the bottom had its derivative showing up somewhere else. Okay. When that happens, that's the thing you want to pick for u sub, right? Whenever you see some like nasty thing like this that looks really like difficult, you want to pick your u to be something such that the derivative of it shows up somewhere else. Okay? So in the example of like, let's say for instance I had like x squared cosine of x to the third. I know that the derivative of x to the third is something x squared, which shows up somewhere else. So that's probably what I want to pick as my u. Do you know that about u sub? Is that like a strategy you know yet, QV?
Yeah. I think that like choosing the u, I know how to do
Good.
that.
All right, great. This is u. Du is this. Okay. So then he rearranges for what dx is, right, in terms of du. And you get that dx is equal to du over 2 times x plus 1. Are we good? We good to hear so far?
Yeah, that makes
Okay,
sense.
cool. All right, now we gotta change the limits. Okay, so you can either change the limits now, or you can do all the u sub stuff and then make sure you plug this back in. Is what you can do, and then do things in terms of x. So I'll show you the two ways to do it. So the one way is to change the limits. So let's remember these things here, right? These refer to the x values, okay? So this is saying, okay, cool, x0 is equal to 1, x1 is equal to 2, all right? So u0, right, is equal to x0 squared plus 2x0. From this equation, right? That's our relationship between u and x, QV. Does that make sense?
Okay. Okay, yeah, that makes sense.
So maybe it makes sense if you like just straight up say, okay, cool, this thing's x0, this is x1, right? Because x's are the values that are the variables I'm working with. This is the change of variables, which are now u's. So my new integral is going to be like in terms of u0 to u1. And when doing that, I'm like, okay, but what's my relationship between u and x? Well, it's what I defined it to be, which was here. So here, u0 is x0 squared plus 2x0. So that's going to be, right, 1 squared plus 2 times 1. That's just equal to 3. And then you do the same thing plugging in for 2. You get 8. Okay?
Yeah, that makes sense. Thanks.
Good. Okay. This goes away. You get integral of du over u, which is the ln of u. And now you don't have to substitute back in. This is the beauty of doing it this way, is that I don't have to plug back in x squared plus 2x in for u, because I've already changed my bounds. If you hadn't changed your bounds, if your integral was still 1/2 integral from, what was it, 1 to 2, and you had this like ln of, and you just had like ln of u, or sorry, you had 1 over u to u. Whenever you do this integral, now it would be ln of x squared plus 2x evaluated from 1 to 2. Instead of ln of u from 8 to 3. And you can see that that's kind of the same, because watch, if I plug in 2 here, right? Do you see how I get 4 plus 4? I get the ln of 8. If I plugged in 1, I would still get the ln of 3. You're doing the same thing. Yeah. Does that make sense?
Yeah, that part makes sense. But the part I'm confused about is
okay, what's up?
How you went from x plus 1 over u to 1/2 integral 3 to 8 1 over u.
Good. Okay, let's do it. All right. So you have an x plus 1 here, right? X plus 1 over u. And then remember that dx is du over 2 times x plus 1. So the x plus 1s here cancel. Do you see that?
Oh, okay. Yeah. Okay, I see that.
Like this is dx, right? And then this was, x plus 1 over u. we left the x. So the x plus 1 here canceled, which was good. And that's what gets me the 1 over u du. And then there's a 1/2 that gets pulled out from here.
Okay, that makes a lot more sense. Thanks.
Okay, cool, man.
I think it was that step that was like confusing.
Yeah. Okay, yeah. You just tell me what the step is. We'll figure it out. Nice, dude. Thank you, Noise, for that explanation. I appreciate you writing that, honestly. It's much cleaner than like I probably would have written it. So, and you have much better handwriting than me. Thank you. I appreciate that, Noise. Here, Noise, we'll give you a bond coin because you basically like did that question. You did like 2 kids' questions today. Nice. Okay, let's see. What else we got? QV. Patty, you still need help with stuff? Let's see if Patty wants to come up. Okay. Which one? The one you posted?
Yep.
All right, let's do it. What is the particular solution to this differential equation with the initial condition?
Pretty much the same thing.
Okay.
The answer that I got was apparently wrong, so I want to see where I go wrong to see,
So I think it's just this, right? If I move it over.
I get that.
Okay. So this is ln of y.
Great. ln y.
And
then it's 1/2 x squared minus 3x plus c. Yeah.
Okay. And then y of 0 is equal to 2, right? Got to put a C somewhere, right?
Yeah. And then it's just ln -2. Oh, wait, it's +2.
Yeah, don't do ln of -2.
Why?
That doesn't work.
I was gonna say, why? Okay.
ln of 2 equals 0 plus C. So C is just equal to ln of 2, right?
Uh-huh.
So now you have ln of y is equal to x squared over 2 minus 3x plus the ln of 2.
I think because I put a negative there is why I got it wrong.
Yeah, negatives are bad. Can't take ln's of negative numbers.
I was gonna say, yeah, you can't.
Yeah.
And then it would be, brought the ln2 to the other side, so subtracted it, so it would be ln y over 2 equals.
Good, I agree with that.
And then
let's see Noyce's solution.
I just put the right side, e to the power of the right side equals y over -2. And then, well, it should be just 2e to the power of x squared over 2 minus 3x. I think that's where I went wrong.
Yeah, this is okay right here.
Negative. I think it's I always mess up my signs.
It's okay.
It's a bad habit.
I agree. Noyce did this correctly. It's actually interesting. Noyce did the solution where, so Noyce got to this part, and instead of solving for C right here, he knew right away he was going to need like a y equals, so he just took e to the on both sides to get a y equals just straight off the bat. Okay. The reason why I did this is because now you have e to like this big polynomial, right? But if you have e to the a plus b plus c, that's the same as e to the a times e to the b times e to the c. You remember our exponent rules?
Yeah. I have one question about that. If, for example, one of those signs is a minus, would that be, for example, if it's a minus b plus c, would it be a divided by b times e to the c?
That would be e to the a over e to the b times e to the c. Yeah, very good.
Okay.
You could also just like write the minus sign in there if you want, but you're right that it then comes on the bottom. Yeah. So the reason he did that, right? Because now we have three things here, and then he ends up renaming this thing, which is technically e to the c, right? He renames it as a. Okay. So this is a cool thing when you're working with constants in integration, is if you ever have like c and then it's like c squared or c to the fourth or like 4 times c or 1 over c, you can just call that whole thing c again. You can just rename it.
Yeah.
You can just be like, okay, well, I'm just going to call this thing a, which is really just like calling it c again. It doesn't matter, all right? It's also the same reason when you do an integral on both sides and you get like plus c, you can always just bring whatever.
Combine it, yeah.
You can combine the c's into a single c. Yeah, good. So he goes right away and just calls this a. And now this is easy because when I plug in x equals 0, this is going to go to 1. This is going to go to 1. And now I just have y equals a. And now you're just like, oh, cool. Well, that shit just equals 2. And now this is super easy because now you already have the solution. You're not dealing with, you know, the e to the ln of y over 2. Like, you're just not dealing with it. Like, the c is already kind of carried out. Yeah.
Can I see the work that... Okay.
Yeah.
So
here,
I'll takes it e to the... Yeah, I'll look at it. E to the power on both sides. And then obviously the constant is just a.
Yeah.
And plugging the 0 in there, I mean...
Oh, a equals 2. A equals 2. A equals 2. A equals 2. You messed up here.
Yeah,
little oopsies.
Yeah, and then e to the 0 power is just 1, so they cancel out pretty much, and then y is just equal to 2.
Y equals 2 e to the x squared minus 3x, yeah.
Gotcha.
Cool. That's a pretty cool one. Thanks, Noyce. I appreciate that one. That's a good solution, Noyce, too. Nice. All right, let's see. Getting a little tired, but I think I'll do one of Swaz's because Swaz wanted some help. I always feel bad. He shows right up and then like he has to bounce. Where are you at? Where are you at? Monkey. We love differential equations. Yes, we do love differential equations. Here, do you want the monkey weight? Where's the monkey weight? It's not that one. No, not that one. No, not that one. Where's the monkey? No, that's Oppenheimer. I have this random. No, we're gonna find it. That's the Thanos. This guy can't go. No. Where's monkey? There he is. There's monkey for you. It's our waiting music.
Your call has been forwarded to an automatic voice message system. 01.
Yeah, Monkey, I put that one in there for you. Yeah. Okay, listen, this is kind of a cool question. An electron travels a circular path with radius 4.6. What is the number of miles the electron traveled during the interval when the central angle formed by the electron's path was 220 degrees? Wow. Central angle. Okay, I think I'm just talking about this. Okay. So, what is this? It's like this, and then it's like this. 220 degrees. Okay. And then we know R is equal to 4.6. Okay. So is that just 220 degrees divided by 360 degrees times 2 pi r? I believe it is. Oh, what's up, Jamarcus? Yeah, nice. Just in time. All right, good. Yeah, I'll teach you Fourier stuff. Time 4.6. So what is that? What is that on my calculator? What is this? 220 divided by 360 times 2 times pi times 4.6. 17.66 miles. Yeah, so this is like percentage of circle. And then this is going to be the circumference. Nice. That's a good one. I like that. That's a good question. Yeah. Okay, cool. Send it to Swaz. Okay. Jamarcus, what did you say you want to know? You want to know how Fourier decomposition works? It's actually a cool thing. So here's the link that he sent. Let's watch a little bit of it. Degrees are the work of three. Yes, it was just an arc length question, Noise. Yeah. Dude, what's up with this ad? Can I start with this ad, please? Okay, here we go. 3 blue, 1 brown. These guys are cool.
This right here is what we're going to build to this video. A certain animated approach to thinking about a super important idea from math.
Yeah.
The Fourier transform.
The Fourier transform. You done some stuff on it? Yeah. Well, how much do you know on it? Are you confused on the formula? Okay, that's fine. Do you want what, like a Fourier transform? I don't want. Do you use the discrete one or the probably this one is the one you're using. Yeah, so you can do frequency in space, or you can do like frequency in time. Because like waves can exist in two different like domains, we say. So waves can exist at a certain position as a function of time, or they can exist at a certain time as a function of position. So maybe let's use like this one. I think this one's probably okay. Oh, they put the 1 over square root of 2 pi. Time, position, time, what? Yeah. No. And then that's the discrete one. We're just like, where's like a nice equation just for the regular one? Yeah, this is between frequency and time. Time, position, time, what? Waves are particles. They're all kind of the same thing. I mean, I'm just what the formula means and where it comes from. Yeah, okay. It comes from like combining a bunch of sine and cosines together. Isn't that really what it is? Right? Here, like, Fourier transform origins. Dude, Noise is getting sorry. Pensender's getting very excited about all the talks of Fourier. Yeah. I think where it really comes from is what is it? It's the imaginary for sine and cosine. Oh, it's cool. Do you want to talk about it, Penn Center? Do you want to come on the stage and talk about it? I know from a physics standpoint what it is, but maybe you know more from like a mathematical standpoint. This is where I think like the origin stuff is okay. So in general, how a Fourier transform works is you can describe anything as a bunch of sums of like sine waves all together. Yeah. So for instance, if I wanted to create I don't know, like a box like this, right? I could describe this as, I don't know, like this wave plus like more of this wave or something, you know, like you basically add up a bunch of different waves at different frequencies and they end up canceling each other out or adding up in such a way that you can create regular shapes. Yeah, we should organize a joint session. I'm down. Yeah, it would be kind of cool. Taking the real part of a cycle of the imaginary plane. I think it has to do with this. I think it has to do with like how you can write sine and cosine as a bunch of like e to the I something, right? And when you're doing when you do a Fourier transform is you're taking the function and you're like composing it, which means you're multiplying it by this e to the I omega x. Is that what they have here? Dude, I can't even read this. Sorry. What? Or e to the I ft, and then you're integrating it over like, for instance, all the different frequencies or all the different times. After that, the math is just calculus. Yeah, I agree. Yeah, it is just calculus. Is it not Taylor series, but instead of using polynomials, you use sine and cosine? Yes. That's a pretty good description as well. Right. Do you know, Jamarcus, do you know how like a Taylor series works? Okay. I wish there was a nice graph of this. I guess there's not. Okay. Let's say, for instance, you have a graph that looks like something like, I don't know, let's say it looks something like this, right? And I'm trying to approximate what the graph looks like right here, okay? One way to do that is to write this as a Taylor series, which just means that, let's say like f at f of x at, let's say this is at c, right, is going to be equal to like something x plus something x squared plus something x to the third, so forth and so forth. And the way to do that is to be like, okay, well, when I just have, for instance, it's just equal to a linear function, right? That's just this. This is like y equals x. So that's how I could probably describe what's happening to the function around here in just terms of like y equals x. But then I can say, okay, let's get a little bit more accurate. Let me see like what it looks like in terms of, you know, y equals x squared, right? And then this is like y is equal to x squared. And then, okay, but then let's add another thing on top of it. So let's see what, like, how many y equals x to the thirds do I have to add to it? And so all you're doing is you're adding up different proportions, different amounts of these increasing degree polynomials on top of each other until it describes this area of the pink graph better and better. Oh, Desmos does? Do they have a nice little thing for that? Let me see. Desmos, Taylor, activity. Is there an activity? Oh, cool. Let's see this. Oh, I like this. I like this. I like this. This is cool. Okay, so for instance, yeah. So this is an example, like this is y equals to sine of x, right? I could describe that as, okay, it's a straight line plus this amount, which is just a y equals x, a linear line, plus, okay, none of the x squared, I guess, plus this much of the x to the third, or x to the third. Oh, I see, but all the other ones are odd. Oh, that's so cool. Oh, this is actually pretty wicked, man. Oh, I like this. Here, let's try some cool functions. Let's try like e to the x. Okay, this is cool. So, Jamarcus, this is a graph of e to the x, right? Which I could describe as, okay, and then you have to define like where you're trying to put it. So let's say I'm trying to describe what e to the x looks like around, what is this? Let's say like a is equal to, what is it? A is equal to like, there, I had it there. A is equal to 1.4, right? Which is around 4. So if I were to have just a line for just y equals something, that would be just y equals 4, right? That describes it the best here. But you see how that's a pretty shitty explanation for what this graph looks like as we get further and further away from it? So what I can do is I can put on top of it another function which has a higher degree. So instead of just y is equal to a number, which is something times x to the 0, I'm going to say it's y times something times x. Okay, so I'm going to be like, okay, cool. If I add this function on top of it, we get something a little bit closer. And then I can add this, and then I can add this, and then I can add this, and this, and this, and this, and you know, we can just start adding like a bunch of these on top of each other. And eventually what you get is you get this purple line here, which once you superimpose, once you add all those terms from the Taylor series on top of each other, you get what looks like the actual function. But notice like it still does a pretty bad job once we get too far away from where we're approximating it. Yeah. So yeah, that's a Taylor series uses polynomials to try and approximate a function, whereas a Fourier series uses sines and cosines. And I believe the definition of using this e to the ikx stuff comes from this property of sine and cosine. You can see that this is just like a bunch of different sums of these ones. Yeah. Because you're going from like negative infinity to infinity. Which means, yeah, you'll get the negative one and the positive one out of that. That's kind of cool. Yeah. Wow. That's pretty dope. Is that why, Penn Center? So, for instance, right, cosine of z is this. It's e to the iz plus e to the negative ig over 2. Which, if when I'm doing an integral, right, from negative infinity to infinity, I'm going to pick up, you know, whatever this one is up here, and I'm going to pick up whatever this one is down here. And that's going to form my cosine. So with a Fourier series and a Fourier transform, is it applying the transform that gives you an infinite Fourier series? No. Well, see, here's the issue is that, so there's a difference between what's called a discrete Fourier transform and an infinite Fourier transform, an IFT and a DFT. So when we were doing the Taylor series, let's see, Taylor series. This is what's called discrete, Jamarcus, because I'm adding up individual terms, like this term, this term, this term, this term, okay? which you can do in a Fourier series, but it's called like a Nyquist frequency. You need like a stepping stone for the frequencies. Let's see, discrete versus yeah, this is what's happening. Okay. So we can think of, in the same way with a Taylor series, that you add up like individual terms of a polynomial, you could also add up individual frequencies of sine and cosine or something, right? That's what this form ends up looking like. You're not really going to do, this is how computers use these to do Fourier transforms, because it's a quick and dirty way and it gets you good enough, okay? The theory says that you need to do it this as an integral. Remember that an integral is basically a discrete series that just has very, very tiny differences between all the points. Or very, very, very tiny intervals. Yeah. An infinite series, yeah, is the actual function. Yeah. Because it covers all of it. Because it goes from like negative infinity to infinity. Wait, what is J? Okay. J is I. Sorry, yeah, they do this in certain contexts. J is I. It's imaginary. It's just I. Yeah, I forget why they do that. I think it's an electrical engineering thing. Oi there, bruv. What's up, Cyber Mage? Yeah. Dr. Nyquist is Bay. Yeah. Yeah, they use J in electrical engineering. Yeah, which electrical engineering is a lot of signal processing, which is a lot of this. It's Fourier transforms. It's whack. Yeah, it's pretty whack, dude. Like, no. Don't do it. Don't do it. More like J-imaginary. Yeah, yeah. But yeah, in terms of like actually like computing an FFT, sorry, that's a fast Fourier transform. But in terms of like actually like computing one, I don't think you usually have to. You don't usually have to actually calculate these things. I usually just dealt with this in computationally, just doing data analysis, like running it through an algorithm. That's what I did. Yeah. Cool. Jamarcus, you know what also would help is if you gave an example of one of your questions from your research project. Like, what do they need you to do with a Fourier transform? Because I can help you on, like, if you're using a Fourier transform to do signal analysis, I know how to do that. I know code-wise what to do with that. But if you need something more theoretical, like maybe you're having to, I don't know, collapse wave functions or decompose something, that's something Penn Center can probably help you better with, because he has a better depth of like the fundamental like calculus that's needed to do this thing. Give him some function. If you want to play the Fourier transform, it just needs you multiply by the function, or would you do that? I'm just asking. You have to integrate is what you have to do. You have to plug that function into here, and you have to integrate from negative infinity to infinity. Yeah. I want to be an electrical engineer. Yeah, be one. They're cool, man. Electrical engineering is pretty dope. It's very good for audio files, too. A lot of, like, sound stuff. Yeah, it uses that. How would you know the function if you're just going to go off of certain values of some graph? Oh, Mary can help? Yeah, Mary does a lot of electrical engineering. Some values of some graph. I don't know. Like the box graph I have, for example. Oh. Oh, like this? Yeah. I mean, this you run through a computer. You do not do this by hand. Yeah. Yeah, well, I guess he's saying like if we just had like a box, right? You can do this using I think you use a computer for this. I don't think you calculate this by hand. Right? Look, calculate Fourier transform by hand. I don't really think you want to do that. Yeah, now we start getting some weird stuff. Yeah, if you're given just a wave, you pray to God. Yeah, exactly, dude. Yeah. Like, okay, here's an example if you want to see like how this actually works. Oh, is it a free PDF? What's a PDF? Let me see the PDF. Oh, it's not found, dude. That sucks. I need to get YouTube Premium. I'll put it on the bill for the nonprofit. I need YouTube Premium. But certain waves like a square wave and saw wave we can do. Can we do a square wave?
Continuous on an interval of this type.
So here's an example of him. So he's given a function, right? This is a square wave per se, right? See how this is a step function, which is like 1, 0, -1, right?
Calculate our area here. Now this will be negative, this will be positive, and they'll cancel each other out. So that was pretty easy. What about the of odd and even?
You have the ringing we talk about, right? The ringing.
Greatly.
Right. But then this becomes an infinite. It becomes an infinite series, is what it is. It's an infinite number of them. But then this is cool. This is the graph of what it looks like. So when Pensender talks about the Gibbs effect, that's this. There's always going to be some ripple at the top. You can't ever get it to be a straight line. You're going to get what's called like a ring. Yeah. Yeah, so you can learn how to use DAX, yeah. Fourier series refers to quantum mechanics in some way. Do you know how that works? Yes. He's probably talking about what's called like a potential well. So a potential well is like this. It's like a square, right? Where like you have just an infinite wall of where a particle can be in between. And then you can use a Fourier series to describe with a bunch of waves how those waves would create that well.
Actual original.
So here, this is a good exercise. You should do this one. Just go through and watch how this guy does it. It's useful. But Fourier quantum mechanics. Yeah, probably something just like this. It's also cool, okay, because, all right, Fourier transforms are a way to bridge things between two different spaces. So when you're doing this, when, like, for instance, you're looking at something as a function of, time, and you're composing it to a function of frequency, you can then also extrapolate that to transform things that are from a function of position to a function of that change in position. So, for instance, that would be as a function of momentum. And in quantum mechanics, you have the Heisenberg uncertainty principle, which deals with there's a relationship between the change in position and the change in momentum, and those can be represented as functions, which then you can use Fourier transforms to split between the two spaces. I guess they call it like momentum space and position space. Yeah, position space and momentum space. Exactly. Yeah, yeah. That's where that comes from. What's this? Dude, stop. I don't want any of this stuff. Yeah, here we go. Right. Yeah, so this is x as p and then p as x, okay? But it looks the same as when we do Fourier stuff, right? Between, in this case, it's u and x, but, where was it? This is, for instance, going between, they do omega and n. Okay, whatever. Discrete time is n, and then, time, which is k, and then frequency, which they call omega, or you can call it k, which is discrete frequencies. Yeah. So this is going between time and frequency, and then in quantum mechanics, you can use it to go between momentum and position, because one is kind of just like the derivative of the other. What's up, Redacted?
Yes, it is me.
I haven't seen you in forever, dude. What's up, dude? What's up?
This is like my 13th account.
You have created a lot of accounts. There you go. Check that out, Jamarcus. I think that's a great explanation.
If you check your DMs, if you see deleted user, I think yellow profile.
Good night, Noise. Oh, I'm sure there are a ton in there, dude.
Buddy, I have, let's see. Now, I think that made it my second or third deleted account.
Oh, man.
Ever. I had another account, but I lost access to it, so I got to this one.
Nice. I'm glad. You should come play Fortnite with us on Saturday. We're gonna play on Saturday.
Womp, I have a life now, so I don't play Fortnite anymore. Not
Okay.
much.
Well, come around, hang around the Discord, dude. We're always here. We're here for you, dog.
Man, I haven't been on this Discord in roughly almost a month.
Yeah, it's been a while. I miss you, dude. All right, let me close out the stream for everyone watching, because we've been going 2.5 hours, and then we can talk more, Justin. Is that cool? Okay, cool. Okay, thank you everyone for coming to the stream. Had a really fun time here at Office Hours. Went through a lot of really cool topics. Appreciate everything that you did. That's me. People say I look like this guy, dude. Like, I'll take it sometimes. Again, thanks to our top subscribers, Sam, Obama, Sensation, Penn Center up there, Magnetar, that's cool, dude, and our amazing Discord boosters. Yeah, y'all are the best. I appreciate you guys. Our next stream is going to be tomorrow. That's going to be an hour later. That starts at 5 p.m. Pacific, 7 p.m. Central, 8 p.m. Eastern. So come on by if you got questions for that. And then, yeah, we are going to have a very special guest for Friday. I got the quantum gravity research guy to meet with us on Friday.
Way.
Yeah.
No way.
Yeah, the quantum gravity guy. Quantum gravity research, dude. Yeah, it's
Did I one time for something quantum physics?
Yeah, here. So, prepare. Yeah, ask him so much. Ask him a lot of good things. Yeah, because this is the guy. It's where was his? Yeah, this was his.
Like professional?
Yeah, this guy. He's a professional quantum gravity research person. Like, yeah.
Damn, 700,000 subscribers is crazy.
Yeah, so this was his.
Two black holes collide.
This was his. He's talking about like anti-gravity, UFO physics. So y'all can ask this guy anything, dude. He's a really smart guy. The squad.
Well, if I were to throw a feather in a basketball in a low gravity room, will they both touch the ground at the same time?
Yeah. So he's gonna be our Friday guest. So I'm really looking forward to that. That's gonna be cool for you guys. Okay, let's see. Which stream am I gonna raid? Who am I gonna raid today? Well, isn't there a command? There's a command, isn't it? Like live? Is this what it is? There we go. Currently live. Actual Education, Danny Highway, E the Pi I, and Professor. Oh wow, there's a lot. Nice. Okay, cool.
So we can ask questions. Right there.
Yeah, you can. Yeah, well, let's see who's streaming. Like, let me see what's happening on stream.
You should totally raid Cypher PK.
Cypher PK, he wouldn't know what to do with it.
Not that dumb. Not that guy.
Not that dumb guy. Yeah.
That guy's a Fortnite streamer.
Let's see. Who's doing what? Is Danny doing math questions, or is Zach doing his real analysis? Who's doing who? One sec. Let me look.
Gotta go. We should play Lego Fortnite for the last 29 minutes I have on my Xbox.
Okay, so E the Pi I is doing his real analysis class. So if you guys want to ask for help, here I'm gonna send you guys to Danny. Danny can help you guys with help. He's working with someone right now. So wait for him to finish and maybe in his chat, like ask him a math question or something and see if he goes over it with you. He says his math help is on. So
will he help with calculus? I got the same kind of concept with a different question.
He would definitely help with calculus. Yeah. You could ask him. Yeah, we're gonna raid him now.
Ask you this.
What's up?
So when you get to college, you have calculus 1 and 3. It's kind of nightmare level.
Yeah, no, calculus. That's okay. It's not that nightmare level. It's okay. Thanks. Yeah, Penn Central will be able to help tomorrow as well. Awesome. Very good, guys. Okay, I gotta go. We're gonna raid. Have fun. Go say hi to Danny for me, and I will see you guys tomorrow. Cool?
Wait, let me see. You're gonna talk to me or something.